Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Coders, step 28. We're going to look a little bit at a new way, or no, it's not a new way. Some additions to the way we draw the screen. Now, from the outset, I was sort of hoping to learn a little bit about how tiles work. They're a big mystery to me. I mean, I know what they are, but why you would use them and what their benefits are, I'm not really sure. So I was also pleased that the Supernatural doesn't use a very complicated way of drawing screens. It's just a list of element types and some data, and it draws that. Now, in this step, I can only imagine that the designer, Trevor Story in this case, I think, yeah, he must have come up with some things that look nice on screen, but they have the properties of a tile. A tile is a number of characters in a square, or in a rectangle shape that belong together, that you want to place as an object, basically. And we didn't have anything for that, so let's look at what it looks like. The initial level has been butchered a little bit to show the new capabilities. Now, as you can see, this obvious block here, this is an area. So this now has one element type that will allow us to draw an area with a single character. This platform is now changed because it's not a regular platform. It's alternating between two characters, as you can see. It makes it a bit more attractive. There's also a vertical version of that, a little bit harder to see, but these are two different characters, so they alternate. And then actually looking at these characters, they look very good. They actually look like rock when you stack them like this, but when you put them in a line, they kind of look different. And these are the tiles that we were talking about, like a little quad of characters, the 4 characters that make up one single thing. So that is the new stuff. There is another quad as well, and we'll look at how these are painted on the screen. Yeah. I'm going to show you how that looks. This is the tiler. We'll open our character project. There we go, and you can immediately see. Let me put the controller away. You can immediately see the tile that we added. It's 4 characters, 4 existing characters: 98, 99, 2, and 3. I think they're existing, although these are new. And but there's another one. See here, there's a tombstone. Also looks nice. So there's again 4 characters and a color selection. Here's a test bed, so you can select a quad and just place them on the screen, and it show. I mean, this looks like a graveyard already, doesn't it? It allows you very quickly to test your tiles. And this is how you would build a screen, right? So, and it would essentially take less information to paint a screen, because you'd only have to record so many tiles to fill an entire screen. Now, this is the character set again. These are the tombstone characters right here. These are the new characters, I think, and these are the ones that make up the bottom row. If I export this, I won't do that now, but it'll create a tiles ASM file, which I can include, and looks like this. These are a number of tables. The upper left, character and color. Upper right, character color. Lower left and lower right. Indexed by tile number. Let's see. Let's see. Yeah, we've. Well, you can see that the level has been changed. This is the alt line. This is the quad, and this is the no object. This is the area. So these are new constants that we've added. We'll see that. Oh, let's scroll up. There's another thing that I'd like to show you. There's a new parameter 6. Uses 0 page location 8. 0 page location 8 is used by BASIC, but BASIC is useless while we are running our program, so we can we can use this area without causing any confusion in BASIC. What else did I want to see? Oh, there's the new constants. They are added here. Area, line, horizontal, vertical, alternating, and quad. These, of course, are used to build the level table. Now, we shall have to look at how these are built, actually. So let's see. All right, here we go. 3406. I've looked at the editor and there is no way to jump to a line. There's no way to bookmark a line so that I can jump to it later. So those are all desirable functions in an editor, especially for the work that I'm doing, by the way. So probably that'll never make its way into the editor. Anyway, let's look at this piece of code. This is the part of the code where we build the screen. We basically read the element type and then increase Y and oh, right. We increase Y. We pick up the screen element that we're building. Yeah, because that's what we read here. And then we transfer that type to X, and we use that as an index into these element tables. And these tables have the addresses of how to handle drawing the different elements. Now, this used to be different. This used to be sort of a jump table, or like an if then else kind of situation where we'd read the element type and then compare it to a value that we know, and if it's that, then we jump here, and otherwise we check for the next value, and so on. That would make a very long table in the end, so we've changed the approach. Now we just have a list of jump addresses, and we index that by the element type, and we get the address and jump to that address to draw. Jump means that there's no return to here. So there is an RTS here, but this is never reached now unless it is jumped to from somewhere else. My guess is that it's not. By the way, I haven't checked, but this is a jump, and that just RTSs out of this call. No, we jumped that. Yeah, it's a bit weird that we have data in our code. Mixing code and data is usually a little risky because things can go wrong that are difficult to debug. In modern code, it's not even possible to mix data and code anymore. I think. But you know, I'm sure this table will move somewhere else in the code. There's been some other moves. The high score code is moved somewhere else. I'm not going to mention that. You know, it doesn't change anything in the functionality. Let's have a look at some of the actual code that draws this stuff. There we go. There's a great wad of code that's been added. Is this it? Yeah, 3658. It's right around the corner. There we go. So, we increase Y because we've just read the type. We increase Y and then we read the X position. We read the Y position of where this, what are we doing? The area where the area is supposed to start. Then we have the X and the Y position. Note that parameter 1 holds the X position. See, this is this is funny. We store the X position in A. We store that in parameter 1, right? And then we increase Y again, and then we get the Y position. A gets the Y position. Now it's transferred to X, and then we get the first character of the line. You know, we get that address. And we point that to 0. We load that into 0 page pointer 2 and into 3 for the character and the color. Blah blah blah. We've done this all before. The high parts, the low parts are the same, but the high parts are different. So that's why we have this funny thing. If you want to know how this works, then you'll have to go back into the videos and listen to me explain how this bit works, because it's the same all the time. So X is in parameter 1, Y is immediately changed into the correct setting of 0 page pointers 2 and 3. The width is stored in parameter 2 and 6. So here's parameter 6, our new one. We'll see in a minute why we're storing this twice. We get the height, put that in parameter 3. We get the character in 4 and the color in 5. And then we store our Y into the stack. And right before we exit this function, we pull Y off the stack again so that the calling routine can continue with the correct Y value. Now here's the thing. Y becomes the X position. A becomes the character. We store the character in the character memory, and we store the color in the color memory. We increase Y. We decrease the width. And if we're not done, then we go to the next character in that area. So we draw that line. When that line is done, we decrease the height. When the height has been decreased to 0, then we're done. If it's not, then we have to move on to the next line. This piece of code is useless. What it does, it transfers our X position, which is stored in the Y register, to A. We set the carry bit. We subtract 40, which means we calculate the X position of the previous line, and we transfer that to Y. Now, in none of the in the code that follows here, Y is not used until we move to jump next line area where Y is overwritten with the correct X position. So this code must have been put there and left there, but it has no place. We'll put my theory to the test. I'll comment this out and compile and run and see what happens. Anyway, what do we do here? We load the low part of the address. Because we want to move the pointers one line down. We load the low part of the address, clear the carry, add 40. That is the next line. The funny thing, oh, okay, it's still it's 0 page pointer 2 didn't change. It's still pointing to the start of the area. So we add 40. We do the same for the low part of the color memory. Then for the next thing, we load the high part of the address. We add 0. Why do we add 0? Because this may have set the carry because there was a page overflow, and adding 0 will then add the carry to the high part of the address. So we're being safe, as we see Monkey Spaz playing PlayerUnknown's Battleground. We clear the carry again and calculate the correct high part of the color memory. Then we get our copy of the, what was it, height? I can't remember. 6 and 2 width. Okay, of course, because we've been decreasing the width right there, so we have to restore it. So we get our original copy of the width, we put that in parameter 2, and then jump to the next line area where we get the correct X position again, which is the now that is weird, because is that X position? Would that then not be? Oh, okay, X position, fine, but that is just on the same line. It does it? X position. Yeah, because the X position, whether you're on position 5 on line 1 or line 7, it's all position 5, right? It doesn't really matter. So this is just leftover bullshit. Let's put that to the test. Let's select these lines. And comment them out. Can I do that? No, what? There was a, all right. Comment selection, right. Let's see. See, there's no change. The area has just been written. There's no problem. Same thing. So this is, we'll probably see this removed in the next version of the code. Let's see. Then there's the alternating one. It's almost the same as drawing a normal line. So we get the X position, Y position, width, the character and the color. Store target pointers, right? So we don't do it immediately, but we know we get the X position. This is again the same code. We just set the pointer straight and save the Y. Then we load X position. Parameter 4 is the character, right? So we store that. We store the color. We increase that. Then we decrease the width. If it's done, then it's line done, and we're done. Jump to next level data. If it's not done, we decrease the width. So this happens every character. We increase parameter 4, which is our character. We load it. We put that character in the character memory. We get the color. We put that character in the that color in the color memory. We increase Y. We decrease the width, and if that's done, then it's line done. Otherwise, we decrease parameter 4 again, which is our character. So in this way, and then we go to the next character. So this is the alternating character code. It's very simple, very straightforward. The vertical stuff is going to be exactly the same. So we've had the area, we've had the alternating. This is the vertical. Well, we're not even gonna next character vertical. This we just the pointers, but when you do vertical, you're gonna have to do the same with adding 40 and then making sure that you add 0 if you do a page overflow and all that. But let's look at the quad, which is 4 characters out of that table. So we get the X position. What happens here? We get the X position stored in parameter 1. We get the Y position, store that in parameter 2. We get the item. So we call it item. It's the tile number. So the tile number is parameter 3, right? So parameter 2, I keep forgetting, it's a Y position. So we get the line number of the. So we set the pointer straight. Then, oh, this is great. Y is the X position. X is the tile number. Now there we go. We look into that table. We index it with the tile number. We get the character. We get the color. Store. Increase Y. You get the character. We get the same. You get the same. Upper left. Oh, we get the same, right, from the upper right color. We transfer Y to A. We clear the character. We add 39. So we add 39 characters. Okay, so we start at A. Then we draw B. If you added 40, you would end up on E. But by adding 39, you will end up on the lower left position. So you get the lower left character and color, increase Y. You get the lower right character and color, and you're done. It's that simple. But this will work only for tiles that are made up of 4 characters. I don't know the tiler very well, but I don't know how easy it is to make larger tiles or odd shaped tiles, but your code will change depending on what the tile is shaped like. And ladies and gentlemen, that is it. And I'm hoping. Oh, Mel in the way again. I'm hoping. Yeah, it's 20 minutes or so. And there's no other changes to talk about. Next level data. We've had that. Just making sure. Yeah, we've just gone through that. White frame. Yeah, some moving code. And that's it. There's really no other thing. So tiles done in a very, very pragmatic and simple way. I'm sure there are many different ways of handling tiles. Some systems rely on tiles. I think I'm not the tile expert, and I don't think this code makes me the tile expert, but I think it's a very funny way of implementing with tables 2x2 tiles. You know, what do you want? Thanks for watching, and I will see you next time. Bye-bye.